Thank you. My name is Ya, and I lead the effort around experimentation across all of LinkedIn. And today I'm going to be talking about work that I did together with Nanyu, who is on my team. If you can stand up and wave your hands a little bit, then the audience get to know you as well. Okay, yeah, that's Nanyu. Okay, so if I make a comment that mobile is important, and I don't think anybody would challenge me in that statement. So clearly, mobile usage has increased dramatically in the past few years, and LinkedIn has declared ourselves to be a mobile-first company, together with many other companies in the Valley and across the globe. So actually, currently, over 50% of our traffic on LinkedIn is actually coming from mobile. And obviously, within mobile, mobile app is way more than mobile web, right? So that's why we're going to be focusing our conversation today on mobile app. So obviously, as the usage goes up, the question comes as how can we ensure that we are continuously improving user experience on mobile app? So if you were listening to Shaolin's talk very carefully, you'll be like, okay, obviously step number one is to define a good metric and run A/B test. Right? So A/B test, very simple, high level. You have user comes in, you randomly split them into treatment and control, right? And then you use the metrics that you defined to evaluate which one is better. But in the mobile world is a little different. So if I can sort of using this very simple cartoon to indicate how changes are happening on the web, right? So as a LinkedIn, we have full control over who sees what, right, for anything that's on the web. So if I'm gonna change the logo of LinkedIn from blue to red, I can flip a switch, users started to see new things right away. Right, so that essentially ensures and helps that any new features that we release can happen constantly and continuously. But the story is a little different with mobile app. So with mobile app, any change, any code change actually takes 3 parties to ship, right? So first of all, LinkedIn has to build and has to submit the build to the app stores, right? So app stores, in particular, Apple Store and the Android Play Store, they have to approve it, right? And then the user actually have to adopt. So it literally is a 3-step process. And as an example, Apple App Store actually, their review process takes about a week, right? And that's not end of it. So if a user, even if after the App Store releases a new version, some users actually takes weeks to adopt. Right? So it's a much, much slower process compared to this instant change that can happen on the mobile, on the web. Okay, so how is that going to impact how we are running experiments and how we are making innovations on the app, right? So it boils down to the kind of change that we're talking about, right? So there are 3 types of changes, in particular in contrast with the changes that we make on the web. So the first kind is what I call server-side changes. Right, so these are the changes that happens on the back end. So any relevance changes, any of those platform changes in the back end of our services, that's the server-side changes. And that is going to stay the same between either mobile app or the web, which is sort of the traditional online A/B tests does. The second type of changes happens on the client. So when I say client in particular, I mean the app that you downloaded into your mobile phone, right? And a lot of the UI changes, and I'll talk more about it, a lot of those UI changes actually are in the client side. So the third type, really big changes that actually cannot be A/B tested. And here today in particular, I'm going to share an example that we did at LinkedIn, which is if you have, who are LinkedIn users? great. If you are not, you should download LinkedIn app. So, so if you have been a loyal LinkedIn user, you probably have noticed that end of last year we have made a big change to our mobile app, right? So in particular, that big of a change was actually we were not able to run a regular A/B test on it, and I will share more detail about it. Okay, as I mentioned earlier, so anything that's server side is done the same as what we have been doing with our mobile, with our web online A/B tests. So I'm not going to touch on it today. I'm going to be focusing more talking about the second type of change, which is on the client side, and also the third kind, which are the big changes. Okay? Okay, so how do we A/B test on the client side? Again, I'm going to emphasize on the differences between the client side A/B tests and the web traditional online A/B tests. So just so that we are all on the same page, the examples that are specifically on the mobile app on the client side are examples such as the look and feel of a button, right, and the number of feed items, for example, that we fetch from the backend at a time, whether to show a fourth call to action on the feed, the search bar, should we have it on all pillars or not, right? So a lot of these UI front-end changes that we have are controlled by the front-end, by the client itself. Just so we're super clear, you can obviously build a mobile app that's entirely server-driven, but I don't think any of the modern apps nowadays are done that way. So, okay, so in that, for those examples, what are the changes that are different, right? So obviously, when you are thinking about designing your A/B test, it will have to be designed a little differently, right? So as I mentioned earlier, you cannot ship code whenever you want, right, as frequently as you want. So there is going to be a lot more plan ahead. So when you're thinking about what are the changes you are going to be making to the app, you wanted to get the code in the build before you ship it, right? So obviously, you can also leverage more parameterization as well. So any of the parameter changes is treated as a config change that you can obviously send it through the wire without having to ship the code or change the code, right? And I always think it's a very, like a thing that I always push for at LinkedIn, and I know that, for example, Ronnie also keeps on pushing it at Microsoft as well, is to A/B test everything, right? Not just new features, bug fixes, and everything as well. And I think because the fact that it's so hard to ship code to the mobile app, A/B test is actually used way more extensively in the mobile app situations because it's used as a safeguard as well, because you can turn on and off features from the server without having to ship code, right? And obviously, there is going to be, because there's so many diverse amount of traffic that's coming from different mobile app version, different platforms, OS versions, and everything. So there is more targeting that's happening as well when we're thinking about mobile client-side experiments. So deploy, which is the second part of thinking about the three-step process in A/B test. So obviously, because we cannot constantly, the client cannot constantly talking to the server, we have to fetch information about experiments. So this is why we have what's called prefetch. So when the mobile app starts, right, the app talk to the server and then fetch all the experiment information at once. And as a matter of fact, when we're doing tracking, if you wanted to do trigger tracking, you cannot actually send the tracking information from the server itself. It really should be the client actually telling the servers that I've actually triggered this particular user experience. There's more detail in the paper. I know I'm going a little bit fast. There's a lot of information here. So the last part, it comes to offline analysis, is, as I mentioned earlier, because when you're thinking about designing client experiment, there's a lot more sort of slicing and dicing and targeting. So also when you analyze it does make a difference when you look deeper at different platforms and OS versions, etc. Right? And I think one thing that is really interesting is also when you're thinking about mobile app experience, because when you are using, let's say, LinkedIn.com, you can, on your mobile phone, you can come through an app. You can also come from a mobile web, right? So there are very interesting interaction that can actually happen between the app and the mobile web. So something to really watch out for as well. Okay, so let me quickly go into the third type of changes, which is what I call the technique that we're using, not really A/B test, but quasi-A/B test. So what are the non-A/B testable changes, and why is that so, right? So as I mentioned earlier, this big change that we give to our mobile app end of last year, it has a code name Voyager at LinkedIn. So why were we not able to A/B test it? Because a lot of changes has to be bundled together. It's a huge, whole new app, right? Not only the front end and the back end, everything has changed. And the entire code base has changed, right? Not just the client code, but also the API code and everything as well. So what do we do usually in the web world if we cannot A/B test something, right? What do we do? So we can flip the switch and hope for the best, right? We can also do canary, which is actually a bit more scientific. You can say, let me deploy these changes to one host instead of all these 200 hosts that I have. That's another option. Not nearly as sensitive and as accurate as A/B test, but sort of good. Or you can do a before and after study. And obviously, we know that it's not really a true A/B test, and it suffers from seasonality and everything else, right? So in the case that we have today with mobile app, it actually gave us an opportunity to do sort of an A/B comparison, right? Remember that I mentioned that it takes 3 steps to actually get the changes into the hands of our user, right? Because actually one step is because the user don't necessarily adopt the new version on day 1. But that also gives us an opportunity. Look, at any given time, especially after I launch my new version, I will have people who is using the new version and the people who are using the old version of the app at the same time. The only challenge is the adopters are not the same as the non-adopters, right? The adoption bias that we have to address. So that's why it's not really an A/B comparison. That's why we create a quasi-A/B comparison. Okay, so just to give you a sense of how bad the selection bias is, here are some data. Okay, so on the x-axis, I have the days after launch, right? So this is the amount of bias on day 1 if you compare adopters with non-adopters, right? So y-axis is the amount of bias in terms of percent delta. So what it means is essentially on day 1, if I compare my adopters with my non-adopters, I see a 50% increase, right? My adopters seems to be engaging with the app 50% more than the non-adopters. And just that we have, we are on the same scale of magnitude of the changes that the product can bring, right? It's usually 10% is already really, really good because the product is already very, very optimized. And if we have a 10% actual difference and 50% bias, we can't really measure anything, right? So just so we are all clear on sort of how we compute the bias, right? We take the adopters, the non-adopters after the app release and compare those same groups of users before the app release, right? So this is what's called pre-launch A comparison. Okay, so one thing that I think it'll be interesting, at least it was actually very interesting to us, is to actually understand why there is adoption bias, right? So thinking about mechanically, how does adoption work, right? So there is really two factors that determines whether users adopt or not, actually. So number one is users' choice of upgrade options. So by default, I think most of the people actually probably doesn't change this upgrade option, is you automatically upgrade if there is Wi-Fi access, right? And obviously different users have a different amount of Wi-Fi access, so that's why depending on how easy it is for you to access Wi-Fi, it determines how often or how quickly our users upgrade. Okay, so if you take a look at our adoption over time, and then if we compare iPhone and Android, it's actually quite different. So adoption happens a lot, that is for LinkedIn user base, and adoption happens much faster on iPhone. It takes 1 week, and Android takes only 3 days on iPhone to reach the same amount of adoption. Okay. And so if you were adopted before in the previous releases, you're also 2 to 3 times more likely to adopt again in the new version as well. Okay, so now thinking about a little bit mathematically, how do we actually correct for the adoption bias, right? Now that we sort of understood a little bit more of how adoption works over time in particular, that helps us to come up with features that can help us correct for the adoption bias. But what are those techniques that's out there, right? So the common quasi techniques, the first one is building a linear regression, a matrix of my interest, right? So this could be sessions per user in Xiaoling's example. So I regress it against whether you were adopted or not adopted together with a lot of covariates, right? Covariates could be historical adoption, could be OS versions, etc. Right? Another very commonly used techniques is propensity score matching, right? So you build a logistic regression, and then you use the score, either use it with matching, or you can use it to use as weights in the comparison. Okay. So we did use those models, actually quite a few different variations of it, and applied on iOS releases. By the way, our Voyager release is across different platforms, so both iOS and Android, both mobile phone and also iPads as well. So we saw it reduced the bias, right, from over 60% to 20 to 10%. Still not very good, much better, but still not good enough, right? And then let's take a look at Android. So Android is actually a very different beast. The reason, how many of you actually know Android actually allows app developers to do a staged rollout? Anybody know that? Okay, yeah, maybe 10 hands maybe. Okay, so the interesting thing is, and it's a misconception that most people had, is the staged rollout actually didn't give us a real A/B test. And the reason is the following, right? So let's say we do a 20% stage rollout. So I have this 20% people who are eligible, but not every person who is eligible is going to adopt, right? But the thing is that from LinkedIn standpoint, we actually don't know who is eligible. Google does not share that data with us, right? All we know is 20% eligible, but we don't know who those 20% are, right? So all we saw is we saw these A1 users who are the adopters, right? And the non-adopters, which is actually a combination of A2, B1, and B2, right? So the adoption bias still exists. As a matter of fact, later I'll show you this adoption bias curve as well. So, but because of the fact that there is sort of a combination of adoption bias and the stage rollout, it actually makes this not a very traditional quasi problem, right? Why is that? Because if you recall the ordinary square models and the propensity score methods that I just mentioned, right? They have this assumption that adopters and non-adopters are actually different, right? And then you can build a model to tease out that difference. But in the stage rollout case, it's very interesting, right? Because the adoption status becomes both user intrinsic behavior differences plus some randomness in it, right? So how can you use the same model to predict with a 20, 80% randomness in it, right? So, however, if you're looking at the bright side of this, is that for every adopter, now we actually expect 4 non-adopters who are very similar, right? That realization help us to actually build a different model that is able to do really, really well. So this is what we call doubly robust with matching model. So it's actually very simple conceptually, right? So step number 1 is when we do matching. So for every adopter, let's say in A1, we try to identify non-adopters who are very similar on the key attributes that we identified, right? So then we take these cohorts that are apple-to-apple comparison, right? So then we run a weighted regression. More specifically, we use the endogenous switching model with a lot more covariates, right, that correct further any bias that we have left. And if putting everything together, this is sort of your estimator, and we have more details in the paper. Okay, so this is my last slide. So this is what the results look like. So again, we were able to evaluate. And I would actually mention one more thing about how we evaluate it. So the bias, if you take a look at it, right, and after lunch, we were able to reduce the bias to within 1% after a day or two. Right? This, if you remember the results from iOS, it was 10%. This is 1%, right? So it was actually the stage rollout, even though the traditional quasi techniques didn't work, but we were actually able to do a lot better because of this stage rollout model that we used. So one thing that I really wanted to call out is it's actually really, really critical to, at least when we were rolling out our new app last year, to actually be able to reduce this as early as possible. We also had a different model that was able to reduce to 1% after 5 days, but that wasn't good enough. The reason is because you wanted to identify any issues as soon as possible, because any bug fix that you put into the app is going to take at least a week to get our users, right? So that's why it's super important to be able to reduce the bias as early as possible. So one thing folks who worked in this quasi sort of causal inference field, you probably have worked with quasi models, and you probably have noticed the one thing that is really challenging with quasi model is to actually be able to validate, right? To actually know how's your model performing. Right? You can maybe know the AUC, but you actually won't be able to know what is the amount of bias that your quasi model is producing. And we are actually able to do that, one, because we were using pre-AA to evaluate it, and number 2 is we actually, even before we ran this in production, we were able to use historical minor releases, which we didn't anticipate any user experience changes to evaluate how our model was performing as well. Okay, so that's all I have. I'm also running almost out of time as well. So if you have any questions, you can ask, or you can ask me afterwards.
We do have time for questions. Go ahead.
Hello. Yes. One comment is, have you guys considered beta testing as prior to the big jump to, hey, there's a new app? Because that could be a slightly less risky.
When you say beta testing, you mean like having a new app ID and put it out in the store and having people just using, like downloading it entirely differently?
There are, multiple models. One of them is having a version that is only available to a set of users. Mm-hmm. Using Test Flight or Google Play, for example, or having a completely separate app with very limited visibility?
Yeah, that's a great question. So we actually do internal beta. So whenever we roll out, we actually we have the capability to roll out our app changes really, really quickly, at least internally, right? So whenever we have a new version, we actually, like every employee is downloaded and upgraded to the new version. So internally, we are all beta users. But I think the changes that we're talking about are not really like app crashes, right? It's really about product differences. That is usually not like be able to identify through beta users.
And my second question is, how much work are you guys doing on making an objective decision on the frequency of releasing? Because I know as an app developer, I would love the changes to be released, but I do know that there's a lot of people who don't like updates every day.
Oh yeah, absolutely. So that's actually one of the reasons we have developed this internal beta user thing first, because obviously I, as a user, will be annoyed if LinkedIn keeps on updating the app right all the time as well.
Yeah, but do you have like an objective solution to it instead of I think it should not be released, but instead of that, like scraping through the reviews or?
Interesting. Yeah, that's a good suggestion. I don't think we've done that. It's not, that decision is not data driven yet. We'll make it data driven. Yeah.
Anyone else? I have one question. You said that there's this big release, Voyager. Did you, for every feature, obviously it takes time to develop that, so for every feature in that you have equivalent sort of small configuration changes in the existing app, which you could, in a previous release, just sort of test it out and build a causal model, and did you do that?
Yeah, so for some features we did actually. So in the version like before Voyager, we actually within that app we tested different things to see whether things would work out in the new version. But I think in the new version that was a combination of those features that were tested and many more, because it's a whole new different experience of user sort of navigation models as well.
Very good. Thank you very much.
Thank you.